Good morning. We will discuss another example how the CPU handles the interrupts. Okay, in this example, let's assume that OS doesn't support multiple interrupts. So, no multiple interrupts, one interrupt at a time. That means when the program is in execution and the CPU got interrupted, so it suspends the execution of the current instruction and jumps to the interrupt service routine. While finishing the interrupt service routine, it will not be interrupted by another device. So that is the meaning, no multiple interrupts. Okay, fine. So let's assume that you have many interrupts like 1, 2 and 3. We are not going to bother about priority because no multiple interrupts. Okay, fine. Let's assume at time 0, the CPU starts the execution of instruction in this address 1000. Okay. And as I mentioned, there is no multiple interrupts. Let's assume while CPU is executing the third instruction, so this is the second, while it is executing the third instruction, it receives the interrupt request signal from the interrupt 2, this one, okay. So let's see, at time 0 it starts the first instruction, at time 2 it starts the second, at time 4, at time 4 it starts the third instruction. Why time 2, time 4? I gave a note here. Can you see the note? Each instruction takes 2 picosecond, something like that. Okay. So at time 4, it starts the third instruction. Okay. While it is executing the third instruction, normally you remember already, we already studied, there is a register in the processor that's called program counter. Normally it contains the address of the instruction what the CPU has to execute next. So while it is executing third instruction, just note that PC will be having the address of the next instruction, which is address 1012. But while it is executing third instruction, the CPU receives an interrupt request signal from interrupt 2. So after the third instruction, it's supposed to execute the service routine. Okay. So what will happen here? Your PC value will be changed now. It's no more 1012. It's going to be the starting address of service routine for interrupt 2. This is the starting address of service routine interrupt 2. It's written in the vector table. Can you see? Starting address of interrupt 2. Okay then, so what is the PC value? While it is executing instruction 3, PC value was the address of next instruction. But you see there got an interrupt request signal. So your PC value will be now changed to, after executing instruction 3, you may see the PC value is now 3000. Okay then, so at time 6, it starts the interrupt service routine and it continues to execute the interrupt service routine. There are 5 instructions. So 8, it starts second one and 8, 10, 12, 14. At time 16, it finishes the execution. Every instruction it takes 2 cycles. Time 6 it starts the first, and then second one is started at 8, third one in 10, fourth one in 12, fifth one in 14. After completing fifth one, it will be 16. So at time 16, it has to go back and resume the user program. Okay then, so where it should go? Okay, by the way, normally when we jump to the interrupt service routine, the address will be written in the stack. We saw in the previous exercise, is it? So the address where it stops at 1008. That means it has to resume back from here. This address will be written in the stack. The context of the current user program is saved in the stack. Okay then, so after finishing the interrupt service routine for interrupt 2, it has to go back to 1012, this address. So after finishing this, it goes back to this address. At time 16, it comes here and it starts the instruction in 1012. At time 18, it starts the next instruction. That means at time 20, it finishes the overall execution. So at time 20, everything is finished. Okay then. So I think you now know before and after receiving the request signal, the PC content I told you already. Before receiving the request, it was 1012. After receiving the request, the PC values changed to 3000. Okay then, so after executing the interrupt service routine, what was the PC value? See, after executing this instruction, what is the PC value? It's no more 3 the PC value. Where to go back? Resume. Where to resume back? 1012. How do you know that? It is saved in the stack. So from stack it takes the value and the PC is now 1012. Then it goes back to the user program 1012. Continue the remaining portions of the user program. After 1012 it executes the instruction in 1016. After 1016 there is no more instructions. So at time 20 all the user program execution is over. Thank you.